Hi, and welcome to the last session of Beginning Linux. We're going to cover a whole bunch of things that we didn't get a chance to put in any other categories, and then you will have had a full and thorough course in how to use and navigate Linux, as well as understanding where the true power of Linux lies. Okay, today we're going to start talking about backups and networking. Backups are important. You don't know how important they are until you don't have something backed up anymore, because your computer has crashed or you deleted something by accident. These things happen. They happened to me. I accidentally deleted 32 gigabytes of music all at once, and there was no way to recover it. I've been very fortunate that my computer work has remained accessible over the course of a decade. I've had one major disk malfunction, and it was Windows. It doesn't mean anything. It was a hard drive crashed, but I do have data on it that I would very much like to get back, and I haven't had a chance to do it yet. There's one place here in Israel called, I think, TikTok in Tel Aviv, and I just haven't gotten there. Anyway, so yeah, backups are important. Why are they important? Because you know, just like I explained, you'll know it when you're missing something you need. Okay, so how do we back things up? Well, at the beginning of the course, we looked at a number of different applications that give you different backup options. Today we're going to go a little bit more old school, and we're going to understand the basic mechanism of what it means to back things up and how to back things up. So let's jump into it. Okay, the first slide, you can't read anything here on the screen, so that's fine. I've flipped it over to so you're watching on the video. Now you can see what it is that I'm actually looking for you to learn. Okay, so rsync, remote synchronization, is a tool that is used to send files from one place to the other. So it has a number of different flags that we use. They're listed at the bottom. Let's take the simplest one, and that is the first command is rsync tick zvh pictures.tar2/temp/backups. Okay, let's see what this means. So rsync is the command. The flags are in order. Z, which means to compress it. So the way rsync works is that the computer that is sending the rsync command files has to actually connect to rsync on the other end. So if rsync isn't running on the other computer, assuming that it is an actual other computer that we're sending it to, then it's not going to work. So just that's something to keep in mind. Okay, so anyway, so the first command, so we're going to compress the data, just helps to send it faster. V is verbose, which means that it will give us a catalog of what it is that we're doing. And H is to give us the data in megabytes and kilobytes, megabytes, and gigabytes instead of just bytes, which can be a long string that doesn't serve any real purpose. Okay, so let's take this first command. We're going to look on it. We're looking at my personal computer, and as you can see, pictures.tar is in red, smack dab in the middle. So rsync compressed, verbose, and human readable pictures.tar to temp backup. Okay, let's see what happens. There you go. It says pictures.tar was sent, 311. All it is a couple of files. We received 35 bytes as kind of an acknowledgement. How fast it went is 600 kbps, which is the internal bus. Total size, and the speed up is 1.05. So by compressing it, we gave it a 5% boost. Now if we list the temp directory in backups, whoops, This temp backup. Hold on a second. What did I do? CD temp this. That's funny. Okay. So silly me. I'm overthinking this. Okay. Now let's take a look at the temp directory. Okay. So I called it backup by accident instead of giving it a folder to write into. My bad. So yeah. So just put it in the temp directory. I didn't prepare the backup. Anyway, doesn't matter. Remote sync. Compress it. Show us what you're doing, give it to us in human terms, pictures.tar, and throw it in the temp folders. Now in my temp folder, I have pictures.tar. Very simple. Takes the file, and if we look in documents, the pictures.tar file is here and here. So it's made an exact copy of it. So if you have computers that are connected, or separate hard drives rather, that are connected, a disk on key. Let me see if I have a disk on key here. Hold on a second. Disk on. No, I don't have a disk on key in front of me. Okay, so if I had a disk on key connected to it, I could easily send it to the disk on key, and it would work exactly the way we wanted it to. Okay. Okay, so now what I'm going to do is I'm going to do the same thing, but this time I'm going to be a little bit smart about it. We're going to call it OTA docs. Make directory OTA docs. Okay, and if I change directory to documents OTA, you'll see that I have being links to assets, artwork, documents, and presentation. Okay, so rsync minus v8, and then we're going to add a, and to archive it. And that was the problem that I was having before, but it doesn't matter. Okay, so from my local directory in the in the documents subdirectory, in the OTA directory, in documents, we're going to send it to OTA documents, and that should actually create the folder OTA documents, right? Yeah, and let's go to temp, and well, you see, created the directory OTA documents, so we didn't have to create it. Computer science education. These are articles that I've written. And what I get paid for. We're not going to look at these files. Open source for homeschool. Okay, so you see all that. It sends it, and then if I list the temporary OTA documents folder, you'll see that it is an exact copy of what is in this folder. So the A file. Now let's do this. Let's run it again. Okay, the A command, the archive command, like I said, it creates directories that aren't created, creates missing directories, and it also is incremental. It means that what it'll do is it will only be aware of the files that have been changed. If I run the same command again, so it sent 230 bytes and received 12 bytes. So it sent a request and got back, everything is up to date, and so it didn't actually change anything. Okay, fine. So this way you don't have to send. Now this is great. This is only 130K, whatever it is. But if you have many megabytes or gigabytes or terabytes even of data, you don't want to keep sending all of it over all at once. You only want to send over the files that you've updated. Okay, so let's go into documents and let's create a let's create a new document here called, okay, whatever, actually just let's copy words.txt Ming. Okay, and now we look and we have two more text files in there, some man page that we were looking at, and words.txt, our words file that we're looking at. Okay, so now what happens if we run this rsync again? See, it only sends the two new files. So it sent the 4K file, which isn't a lot, nice and quickly, and because it was text, it compresses very nicely. So it compressed it to took 1/32 of how long it would take, and of course if we run it again, it does absolutely nothing because it just had already sent the files. So if we look at my cron jobs here, you'll see at 2 o'clock in the morning I sync all my documents into backup Mark. Actually, I want this to be documents. At 2:30 I want it to sync up to pictures. At 3 o'clock I want it to sync up to my projects, and at 3:30 I want it to sync up my videos folder. Okay, so we're at my cron job, and then if I look here in my root directory, so I'm my documents, my projects, my videos, and my pictures are all backed up incrementally. So as I work during the day, I do different things. I do Git stuff, and I do document writing and articles and stuff. And at night, when my computer's on, but I am hopefully fast asleep, my computer will simply take the day's work and shovel it off to where I want it to go. Okay, where do I want it to go? That's a good question. So if we look at, let's look at the next one, rsync avz. Now all of a sudden, you'll notice that we dropped the H. Why do we drop the H? Because we really don't need the H anymore, because you see we're setting these things to, actually we don't even need the V, because we're setting it to do it automatically using cron. So I don't need to see the output, and the output doesn't need to be in human readable format. Okay, so where do I want to send it? Let's say I want to send it to a different server. So I give it the username and the server name, and then I tell it where I want it to, to download to. You can actually see that in the cron job is that I've set it up like that. So all these commands are rsync, archive format, and compress them. Let's do this as quickly as we can. And I want you to take videos, and now I want you to send it to a computer that I on my network called Zion, with an X, because I'm a hacker. Okay, so this is a server that I have. I have 2 of them, actually 3 of them. One of them I gotta resuscitate. So what I'm doing is I'm saying, okay, I want you, now it reads it as a username and a host name. So I am user Mark on my server, and I connect to, and the server I'm connecting to is called Zion. And my computer knows, and we'll take a look in a little bit, how my computer knows where to find this computer named Zion, or specifically what the IP address is. Okay, and once you've found that, once you've authenticated, and the way we authenticate is using SSH, which I'll talk about very briefly, but a lot more in the server building class. So I want you to then put it in the folder from the root. There's a folder called backup, and then there's a folder called Mark, and then I just added it into the folder called videos, because I actually was moving too quickly and it splattered everything all over the place, so it's a little bit sloppy in that folder, whatever. Okay, so and that's the same for each of them. So when we're connecting to another computer using rsync, you're using SSH, you have to give it a username and a host name. You have to be able to authenticate it in some way, and that I'm using SSH in order to authenticate. Okay. All right. So that is what this. So that's what number 3 is. Number 4 is rsync and human readable. Okay, so now we want to see it human readable. Obviously, the needs are different. When we're running it through cron, we have no need for output, and we have no need for human readable. So you modify it the way I'm not going to talk about it anymore. Okay. So now look, we reversed it. So what this is saying is go to that server, go into that directory, and then bring it local. And it works like that also. And it's got, there's no problem with that. So, either you're sending it from your computer or you're restoring from backup, as it were, from another location, from another server. Okay? The E switch specifies which protocol to use. It does it by SSH by default, but if you want to be explicit about it for whatever reason, you can explicitly state the protocol that you want to use, and then again either bring here or go there, depending on the order in which things are put. Okay. Okay, so progress, it'll show you a progress bar, include and exclude. If you want to ignore certain file, exclude certain types of files, certain directories, things like that, you can do that. Okay, delete removes files at destination. So that means if you need to bring something and then delete it, it will bring everything over and delete it. And then if you want to clear your computer from whatever it is, or vice versa, obviously delete removes it from the second file, and source removes it from the first path, second path and first path. Dry run will do everything to make sure, if you add that, it will make sure to do everything to actually transfer the bits. It'll show you what'll happen if you're actually doing this, but if you think that you might have messed up, and then use dry run, and then the A command is for archive, meaning incremental, meaning if it notices or registers that the file has changed, it'll just change that file. Any non-changed files, but in case you want to do a fresh sync, so you use capital W, and it'll throw over the entire file or files. Okay, so rsync, great tool. There are other ones. There are some that are based on this one. Others, but this is a very simple command line way. Use command line and cron, getting things from wherever you're working to wherever you want to keep it, so that if the worst should happen, you would not lose the amount of, you wouldn't lose all of your work off of your computer. So it happens to be, let's connect to me at my computer, and right, because so, oh my goodness, come on, I should be using FC, but whatever. SSH Mark it's on, and it connects me to my computer. Okay, if we do a look-see at what I've got going on, you'll see on one hard drive that's connected, the main hard drive is about 2/3 full, was 100%, had to clean that out. I have another USB drive that's about 35-37% full, and then I have this backup folder, which is actually another USB drive. It's actually a USB thumb drive, and yeah, take a look at that, because I didn't. Yeah, that's a 2 terabyte thumb drive, and I've filled it with 55 gigs, and it barely makes a blip. So these things are cheap. This one was a little bit difficult to work with, but eventually I got it into shape. I had to do with creating a file system on it. It was a little bit of a mess, but we did get it to work, and now it is backing up. If you actually want to see what the mess is, yeah, and so it's like, you know, I just took everything and just dumped it into this, you know, into this directory without thinking about it, and so eventually that'll clean up, and I'll be able to get on with my life. Okay, enough of my mess. Okay, networking commands. Well, your computer is connected to other computers through the internet. So there are different tools that we as Linux users can employ to determine about the connectivity of it. So the first is your IP address. Every computer has an address that the information flows to. Now, a router takes the information, like holds the request information, and then when it receives the response information, it redirects it back internally to the IP address of the computer, or rather the computer with the IP address that was making the request. So if two of you go on separately and you go to two different websites, and your router, the one that you get from your phone company or your cable company, so it actually knows that you're in two different IP addresses, and it is smart enough to be able to get your request to, you know, one request to computer 1 and second request to computer 2. Okay, so how do we know what our IP address is? So if we look at ifconfig, ifconfig tells me what we have, what I have in terms of network interfaces. That's what the IF stands for, interface config. Okay, so I have three interfaces. The first one is a loopback, and that is itself, 127.0.0.1, that's very common. The 1.1, 0.100, it could be anything, doesn't really matter. 127.0.0.1 is your own computer. It knows, according to the rules of TCP IP networking, 127.0.0.1 is your own computer. So that's the first loopback interface, and that is okay. That's I can't think. Okay, ENP3S0. So that's Ubuntu is giving me some bizarre Ethernet configuration name. I don't know why it doesn't give me just ETH0, but I don't care. EN stands for Ethernet, and I know that that's the wired one. So I don't have I should, and I don't. I don't have anything plugged into my Ethernet jack, so it does not have any connection. No packets transmitted, no packets received, no packets transmitted. Nothing's going on. Okay, fine. The third one, so that's my wireless. Okay, and my wireless is connected. So according to my computer, I have the IP address of 10.100.105.99. That means that, you know, and I'm not going to get into private network addressing or public network addressing, but suffice it to say that 10.anything is not routable on the internet. That means that there's no Amazon Web Service computer that is publicly known as 10.anything. It's a private subnet. There are three different private subnets. There's 192.168. There's 174. Something, I don't remember. And then there's 10.0.0.0. And with these, you can create different networks, different network branches. So I actually have three network branches in my on my network. I have 10.100.102, 10.100.104, which is the house, and 10.100.105, which is my office network. And when we have guests in our guest apartment, and I move the router there, then it's for guests. Okay, so I am connected to that network. Now I've actually told my computer that I always want it to be 105.99, so that's hard coded into my computer. I wrote that into a file. Okay, so knowing that my address is 10.100.105.99 is important if you need to, if you need to know that information. Now, if we go to a server that is on the internet and we take a look, now you see this Ethernet. Okay, it's a virtual machine just like you're using, but this Ethernet address is actually 174.138.10.182, and that is publicly accessible. The 174A node is publicly accessible. This is another one that isn't, but whatever. Anyway, so this is, I'm not going to bother looking it up, but maybe I'll write a note. If you really need to know, I'll tell you. Okay, it doesn't matter. So this is publicly accessible. That means that if you type in a browser 174.138.10.182, you will actually get to this computer. Whereas if you typed 10.anything in your browser, if there isn't a computer on your network that is has a web server on it, nothing will happen, and the browser will just refuse to connect and tell you you're crazy because you're trying to connect to something. Okay, fine. All right. So that's IP config. Traceroute. This is fun. So let's say I wanted to. I was curious, and I wanted to know exactly how does my computer connect to that server. Now I happen to know that the server is in Amsterdam. I have a server in Amsterdam. I run a server in New York. So I got servers all over the place, and all these things are connected. This is the internet. So my computer with its wireless is connected to my wireless router, access point. The wireless access point is connected by wire to my router. My router is connected to the phone service. So the phone service is connected to inside the phone box on the street. It's called the DSLAM, so it's for DSL. The DSLAM is connected to central routing in the phone, in the phone company. Eventually, the signal leaves somewhere in Tel Aviv, and it goes through either underground cables via Cyprus to Greece, and then into, or it can go by satellite. Like, it kind of doesn't really matter. But if we're curious, or if your network is truly slow, or if you can't get to something is you're expecting to get to a website and you can't get to a website, you would use traceroute to try to figure out what it is that the problem is. Okay, so if we go to traceroute 174.138.10.182, what it does is it now tells you exactly what's going on in order to make the connection to that server. Let's see. It actually connects. No, it doesn't. Okay, fine, no problem. Okay, so we're trace routing to, and if I gave it a domain name, like if I did the same thing, traceroute.mgcsdev.com. Okay, it's the same computer, but here it gives it, so traceroute to the domain name, which actually resolves to this IP address. Okay. Oh, that's cute. Okay. And you'll see that it's basically giving us the same reading. Okay, so first it starts from my computer, then it goes to the main gateway for the subnet, which is the access point. Then it goes to, it goes to the main router, and then it goes to, I don't even know what nv.net.il is, but HFA I'm assuming is Haifa. So it goes to, so it jumps from 102 to whoever is running this service, and so on, and it goes from there up, So this is the gateway server that it goes to, and then you'll see that the gateway server is actually 10.10.31. So that's an internal IP address, a private IP address, interestingly enough. And then it goes from, so it goes to the gateway, and then it goes to this computer, which doesn't identify itself, 80.249.260. I have no idea what this is. And then it makes 30 more hops to computers that have chosen not to identify themselves. Okay, that's boring. Let's see if this will do any better. Okay, so all this should kind of be the same. It is until we get to here, and again, I don't know what. So from here, it connects to. So from inside, from Haifa, it jumps to London. From London, it goes to New York. New York, it goes to the DigitalOcean. It goes to DigitalOcean main. It goes from New York to. Okay. Again, it jumps through all these different computers, and each of these computers report back what they're called and what their IP address is. Okay, and then eventually gets to DigitalOcean. DigitalOcean, again, there are internally, DigitalOcean is obviously not willing to tell us, or we don't know where these jumps are going to. So fine, okay. You kind of get the point. So if there was a problem, so if something failed, you can't get to it, and it failed at step number 2, that means your router needs to be rebooted or something like that. You know that the problem exists on your end, whereas if there's like a fire in London or whatever, and internet traffic is dead because the switching station blew up or whatever, God forbid. Then you know that the problem isn't yours, and you would hope that at some point your traffic will be rerouted. Okay, that's traceroute. Okay, ping is the same thing, except that we don't care about all of the hops that it makes. We just care. It just tells us if the computer is alive. So if I ping 10.100.102.1, okay, that's my router. It says it's fine. 102.230 says it's fine. That Xeon computer, that's 102.100, that's fine. So you're taking 3 milliseconds to do it. Okay, very, very, very quick. And if I ping marcgottlieb.com, okay, you see that it's okay. Yes, same computer. Okay, so it goes all the way to that computer, and you see that it's taking 91 milliseconds to do it. So it's obviously some sort of distance, and time. There is a distance factor, but it tells me that the computer is actually working. So this is important. Again, if you have a network of internal computers and you're trying to ascertain if a computer perhaps got shut off because your kid's sister tripped over the cord or something like that, someone was playing with it, power outage, whatever. So you use ping, and if it says host unreachable, then you know that there's a problem. If you get a ping back and the time is like excessively high, it means that something's going on the server that needs your attention because it's grinding to a halt. Okay? Alright, so let's say you want to know a little bit information about the domain name that you're looking at. Let's take marcgottlieb.com. So it's the domain internet groper. Domain internet groper? I think that's what it's called. Dig marcgottlieb.com. Okay, what this does is it tells us a little bit of bad choice. It tells us information, and what it actually told us is that I already have this information in privately, so I don't have to actually fetch any of that information. Okay, all right. Let's think of a QN.com. Okay, that's my food blog. What's going on? I have that also? Okay. What is, okay, what am I doing wrong? Okay, let's just try. No. Thing. Okay. So. All right. Why am I getting upset here? There we go. Okay. So weird. Okay. So the dig command with the @ sign, it says, what server do you want me to ask? So in this case, I'm asking a name server that I happen to know and use, and we can also actually query. There are a couple of public ones that are really great to use. 1.1.1.1 and 8.8.8.8 is another one. So locally, it's just getting information from my computer. I must have set it up. I must have a DNS server running somewhere, but in any event, doesn't matter. Okay. All right, so we can ask either 1.1.1.1 or 8.8.8.8, and we will get back an authoritative answer of what we know about this server. So right now we're asking it, what's the address, the A record, what's the address record of KeelNarkKosher.com, which is my blog. And it says the address according to 8.8.8.8, which is a Google server actually. 8.8.8.8 knows that KeelNarkKosher.com resolves to 174.138.10.182. Correct. Okay. Okay. So now let's look at a little bit more complicated one. So I had hosted it at this Also Networks company for a while, and it has a lot more information about it. And so it has the address, the correct address, and it also knows that it is the resolution, or it thinks that it's the resolution authority for KeelNarkKosher.com, so it lists it as the authority name server. And then it has actually other address records which are no longer in effect. So this is actually, so that's the quantitative answer is the first answer. That's the A record. Okay, and if we now let's change it up a little bit, and okay. So what type of record am I looking for? I'm looking for the mail exchange record. When I send email, where does it route to? Okay, when I send email, it goes to this alsonetworks.com. They handle my email and for KeelNarkKosher.com. If you send me mark@KeelNarkKosher.com, it'll send out to this mail alsonetworks.com server. Okay, which then knows where to file it, and then my local mail program is the one that goes and fetches it and picks it up. It actually isn't true. It actually forwards it to a different email address, but that doesn't matter for all intents and purposes. So that's the mail record. Okay. Now I believe. Okay, so if we want to now know all of it, okay, so there's the start of authority record, and that is, where the internet knows to start looking is here. So that's the start of authority record, the name servers that handle the request of routing it, the actual address record, and then the mail exchange record. Okay, seems simple enough. mgcsdev.com. Okay, so again, we have the start of authority. DigitalOcean is handling mgcsdev.com. The name servers, the address is this 10.182, which seems to be my address for everything, which makes sense. Start of authority, and then I have this text record, which is it's called an SPF record. It helps to prove that my server is who I actually say that I am. Because I have control over DNS, I can reinforce the fact that I'm in charge of particular records. So, and that includes this other website that I control, CompuCamp.tech. Okay. So lots of very interesting stuff, and so Dig gives you that information if you're nosing around and looking for it. Okay, let's go to the host. Okay. Okay. Let's see. MGCS. Okay. What did I want to show you with? No, I do not remember why I wanted to show you. Okay. Alright, I'm going to give us one more. Okay, so fine. So it wants me to. I know what my problem is. Okay, you want to see what my problem is? VI. Sudo VI. Etc. resolve.conf. Okay, yeah, I'm going to take this and block this and tell it don't look there. It's not smart enough to deal with it, of course. Okay, there you go. So host marcgottlieb.com, similar to Dig, a little more high level. So if you just type the host, it'll give you a friendlier version of what we can find for Dig. Okay, great. And let's look up. Same thing. Tells you marcgottlieb.com is the address. These are just different tools that are used. They have different specialities. Use the man pages to figure out what the difference between Dig host and its lookup. I use Dig. I'm aware of these other programs. I use Dig. It just gives me all the information that I want. Kind of easy for me to find it. Okay, so that's all external. Let's say, what happens internally? How does your computer know? Well, according to Linux, it keeps a routing table, which we can look at if we look at the routing table. Okay, so the routing table for this computer, it says the default destination, which means kind of anywhere. Send all the packets to 10.100.105.1. It'll know what to do with it. With a mask of 00 means no mask, meaning to any IP address possible. Okay. Flags. What does Z stand for? G stands for gateway. And metric reference and use, okay, don't care, and which interface it's connecting to. So if you had multiple Ethernet ports, like I have a Ethernet, I have wireless, and I have a wired connection on my laptop, I could theoretically hook them up to two completely separate networks, and my computer could actually be the bridge network between those two networks. Just we identify which interface it is. So it knows the wireless one, and then it says to anything in the 105 subnet, because I belong on 105.0. That's my wireless. So it has gateway is. I don't even know what the star is. The star should be nothing. It doesn't mean any, or it shouldn't mean any. And then but then it can access anything from this 255 is completely blocked, nothing of this, nothing of this, nothing of this, and anything from 0 to 255. Right, 0 to 255, 256 being base 8. Okay? Alright, so that route tells you internally what your computer knows, how your computer sends its packets and through which interface it sends its packets, and which packets it has to target. Okay, so this is Xyon, and we look at Xyon and we see that it has two additional settings that I added to it. It has 104.0, so its IP address, if you remember, is 10.100.102.100. Okay, that means it's on my 102C node, or my 102 subnet. Okay, so it can be aware of any of the other computers that are connected to the 102 subnet. Now I have these two other subnets, 104 and 105. So if I want to reach anything on 104, what I do is I send it to 102.2, which is the other access point network address. Like so if you have it, I'm going to try to explain this. So it has an internal external IP address. The internal IP address for 10.100.104.0 subnet for that access point is .104.1. It's typically 1. Sometimes it's 138, sometimes it's 254, can never be 255. Anyway, so 104.1. So that's its internal. So it can see everything on anything that connects to it from wireless, which is its internal connector. It sees 104. Whatever, and it can transmit to 104. Whatever. When it's plugged in, it's plugged into the 102 router, which, and I've assigned it, I've told it that it's device 102.2 or 102.5. Should be 102.4, I don't want to get into it. Okay, and and those machines know that 102 is the gateway interface to the 104 subnet, and 102.5 interface is the gateway to the 105 subnet. You can see all this in the routing table on my server. Okay, I have similar routing on the other server that I have. Okay, if we type in host name, you'll see that it gives the host name Xyon. Okay. You see that there's a file in the etc directory called hostname, and when I type in hostname, it accesses that information. Now you can actually change that information using, depending on what your level of availability is, what your level of permissions are. You can actually set domain names, create aliases, do a whole bunch of other things that the hostname command will allow you to do. Nothing terribly complex, but in case you're completely confused, let's say, for instance, you did not have, you see on the bottom at the prompt, it says market Xyon. That's how I set the prompt in my bash settings. Okay, let's say you were silly and you just set them all to the date timestamp, right, or whatever, and you're like threading your way through different servers trying to figure out what's what, and you have no idea what server you're on. Type in hostname and bang, it gives it to you right then and there on the command line. So you figure that you're on the wrong server, and that's why you can't find anything, so you back out of it and you go to where you need to go. Okay? Alright. Whois is not really a security command. I should have changed the name on the slide, but it doesn't really matter. We'll take a look at whois anyway. Whois tells you all the information about a domain name. A domain name is a string of characters that you got to first, that you have registered, and as long as you continue to pay the fee, you will be granted exclusive rights to use that string of characters in that order. So, for instance, if you wanted to register google.com, you can't. Why? Because the good folks at ABC Incorporated have already registered, and they probably registered for the next 50 years. Let's find out actually when Google expires. So let's say for some bizarre reason Google forgot to renew their domain name and it expired. Then you could get the Google domain name, but it's not going to happen, so don't hold your breath. Okay, so if I ask who is google.com, now it gives me all sorts of information. The only stuff that you can see is this legal text, and we don't care about that. Here's the information. The domain name is google.com, registered by this ID, who we don't care. The server that gives this information is called whois.markmonitor.com. We're going to copy that actually. We can go, the registrar is the company that registers the domain name. The registrant is the person who owns the domain name. Okay? It was updated in 2018. It was created in 1997 and on actually September 15th. And it expires September 14th in 2020. Something tells me that they're on top of things and you're never going to get this domain name. Okay, fine. And just in case you're interested, at 4 o'clock Zulu time or Greenwich Mean Time. Okay, the name of the registrar, the INA, blah, blah, blah. If you have a problem with a domain name, if you are being spammed by somebody or whatever, you can actually find the abuse contact email by doing a whois, and you can complain to them and say, I'm getting spam email from this, I'm getting spam email from this, and please stop it. And then, according to the terms of service, they need to take it down or send a threatening letter or something like that. Okay, and a phone number that really works. Okay, different statuses show you. Different statuses show you the whether or not you can delete it or transfer it. Okay. Obviously, we're never going to get Google.com. But more importantly, it has the name servers. So when you type in Google.com, the only thing that the internet knows is that all the information that we want to know about Google is here located at ns1.google.com if you can't get that, ns2 if you can't get that, ns3 if you can't get that, ns4. So if we go ahead and dig again, google.com, okay, if we go to google.com, so we see that google.com has, here are our name servers and mail that you can send through Google. And I mean, obviously these aren't single servers, these are whole server farms. And you'll see that the A record actually keeps changing because it's balancing the load, because Google gets, a million hits a second on their domain name. So 172.217 appears to be owned by Google, and then it has everything from 0 to 55 in both the C node and the the fourth segment of the IP address. Okay, fine. Okay, so what happens is that when we type in google.com, your computer says, do I know where google.com is? Yes, no. If it doesn't have a record of it, it goes to the next in the server, the DNS name server, the name server list, and it requests the information. And the information says, oh yeah, I know where it is. It's at ns1.google.com. So then your request gets rerouted to ns1.google.com. ns1.google.com says, oh yeah, I know where it is. It's at 172.217.22.14, and that IP address says, oh yeah, I know what to do with this IP address, and it serves you Google's homepage, or words to that effect. I mean, I'm oversimplifying it because Google is obviously a tremendous mechanism, but suffice it to say that that's the basics of how it works. That's how it works for any website that you're going to set up. and any domain name that you buy. Okay. All right, so that's who is. Now, UFW, let's go to... Okay, so let's go to my server, and okay, it looks like I have to update it. Fine. So let's take a look at UFW. UFW stands for Uncomplicated Firewall. Okay, fine. UFW, and when we look at UFW, status, no. No, okay, no check. UFW status, okay, there you go. So my firewall on my server, okay, it says VPN, you're allowed to VPN, which I have to shut off because I'm not actually using it. You can connect to it using SSH. You can connect to it using 443, which is HTTPS. And then you can connect to it to port 80, which is HTTP, which actually just flips you to 443, it doesn't matter. So from anywhere on the internet, you can get to this server on these 4 ports, okay? And it really should be 3 ports, but I'm not dealing with that at the moment. Okay, now from any of these IP addresses, and it's a long list, right? From any of these IP addresses to any port whatsoever on my computer, they're denied. Why? Because they tried to hack into my computer. That's it. They tried to hack in. It didn't work, and I have a script that I actually do not have as a cron that I run against it. Okay, now you can also see that 25.587.465. Okay, so what these say is that anybody that tries to connect to my computer on these 3 ports is denied. That these are my mail transfer ports, 25.587.465. So I only want to be able to send out email from within my server, i.e. Status reports and WordPress emails and stuff like that. So I can send them out, so those ports are available to me to send out email to where it belongs. But if anybody tries to connect from the outside to these ports in order to relay mail through it, they're denied. Okay, fine. More miscreants, more miscreants, more miscreants. Okay, and then V6 is IPv6, which is a way that gives us more IP addresses. It's catching on, but right now the 4-number dot notation IP address, that's what we're using pretty much for the time being. Okay, so uncomplicated firewall. Let's take a look at how we do that. Okay, more. Okay, so we're going to look at what's called a bash script. Okay, this is just commands that are written in a language called bash, the bash shell, which we've been using. It's a series of commands that we issue. Okay, the first is what interpreter do we want to use? We want to use the bash interpreter. Okay. Oops. Okay, so using bash, while IP address is being read, do this. Find whatever's in IP address and then extract if you see something that matches XML RPC. Somebody's trying to attack my XML RPC connection in WordPress. So somebody's doing that. I want you to print the first column entry, which is the IP address. Okay? And then if it isn't blank, Okay, then, okay, echo it, which we don't really need to do, and then issue this command. UF the uncomplicated firewall, deny from whatever IP address was taken out of my logs as having attacked, trying to attack my server, to any, okay, so deny anywhere, and then take the output, whatever gets outputted, and dump it to nowhere, and that is also for the error and also for the output. The output and the error all get sent to the nowhere zone, okay? And then close the if, and then while do done, and where do I get IPADDR? IDAPPR is each line that comes out of the Apache log that I give it. So let's take a look. Let's take a look at var log, and okay, take a look at, do we have that yet? Okay. Oops. Okay, so look, we have access, cooking, error. Okay, so we have a bunch of things that are going on, the access log. Okay, so now what we're going to do is we're going to take everything that we've learned and we're going to put it into motion. So we're going to take a look at cooking.marcgottlieb.com access log, and then we're going to grep for XML RPC. Okay? And what it's going to do is it's going to show me really nothing. Okay. So it's going to show me one IP address that has twice tried to hack my my XML RPC, trying to send data, post data, or send data to this XML RPC in an effort to try and get my in order to get in and hassle me. Okay. So let's take a look at the log that was rotated out. So this one has a bunch more. See, this is, you see, so this guy is really banging away on my drum. This is 43.242. Okay, so this is what we're going to do. We're going to go back to root. Okay, and we're going to run UF the uncomplicated firewall IP sh, and we're going to give it the we're going to give it the log file, this one, okay? Actually, well, okay, well, first we're going to give it this one because it's much shorter, and there, okay? It reads through the log. It finds the IP addresses, and it now okay, 1, 2, 3, 54, 57 to 54, 142 is now denied to my server. That's it. You keep trying to attack me. Right now, my server will simply deny the request. They can no longer get in. Okay, that's great. So now if we take it to this other log file, that big mess up there, what I'm going to do is I'm going to run this command. And now, okay, UFW is ignoring duplicates. Just I've squashed the output, so I don't really care. So this is just dealing with it. I probably could check if it's there, but I really don't care enough. Because I don't run the script automatically. I just run the script whenever. Look at this guy. Wow, they really had it bad for this server. Well, too bad for them. Anyway, so I could probably check to see if it's already an existing thing. I don't care. I just run the script. It's not a terribly complicated script, but it's significant in that this moron from 43.242, 135, 130 can no longer access my server and cause trouble, or at least that's what I'm hoping. Okay. So it gives you a little taste on server administration and networking and how to protect your computer. There are a bunch of other, okay. And we've now come to the end of the course. Wow, okay. We have looked at the basics of it, what Linux is, setting up your environment to make it friendly, using programs to get things done, and then gotten directly into the strong and flexible and powerful command line interface that gives us access to do things that I honestly don't even know if they could be done in other operating systems. I suppose Macs more or less, but Windows I wouldn't even know where to start with that. So we've covered file permissions, cron, archiving, and then a whole bunch of utilities that help us work in Linux. A number of ways to manipulate commands so that we can get parts of other commands and we can write results out to files, and then a number of other commands that help us on the command line. There are tools that Linux can be used to do in order to change from one file type to another file type, and then backing up information, how to find information about the network environment, both internally and beyond your own computer. I had a lot of fun teaching this class. Thank you very much for being attentive students, and I will see you in my next class. Bye.